Common logs. What is a common log? It is a log with a base 10. Log base 10, okay? So it's written like this, log 1000. It's found in your calculator, and it's actually found in most scientific calculators. It's this button right here next to the number 7 that says log. That log in your calculator is log base 10. It's not base 2, it's not base 3, it's base 10. If you happen to have a scientific calculator, and again, depending on where you go into college, whatever your teacher is, but you can have a scientific calculator is the ones that have your sine, cosine, and tangent inside of it, but they don't have the graph part. But right here, you're going to see log 10, and that your scientific calculators also have it. Because there are I think at NC State in the engineering department, you're not allowed to use a graphing calculator, but you are a scientific calculator. So the students will do a lot of stuff in the scientific calculator, just so you know. But what does this really mean? So again, there is an understood 10 right here, but it's not written. There's an understood 10 right there, but it's not written. And so if you were to solve this, what is log 1000, remember, you could set it equal to x and go like that. So 10 to the x equals 1000. What would x be then? We just took a whole test on this. 3, right? 10 to the x equals 10 to the 3. X is 3. And you can, again, check it in your calculator just to show you. Just hit log 1000, 3. It's really cool. Okay, it's helpful in so many several ways. So first part of your homework tonight, get this down, is evaluate, and you will be allowed a calculator. And you just have to evaluate logs. Log 32, log 2 to the 7th times 5, anti-log of 0.3012. So again, you could, every book is different. So I was going to give you this worksheet, but I'm going to safely assume based on the quiz that most of you could understand your properties. You did your properties pretty well, but some books will actually say, log 4, let me actually find out what it is 0.602, and log 8 is 0.903, and they'll say, okay, figure out log 32 based on that. Do you know how to figure out log 32 then?
Add them.
Why? You are correct.
Because of the properties before. 8 times 4 is 32.
Exactly. Log of 8 times 4 is 32. And what do I do when I multiply inside of log? I can actually separate it by saying log of 8 plus log of 4. And so I can add these two together. There's log of 8 and log of 4. But honestly, I'm going to even make this way easier for you. Ready? Log 32. 1.5. But that's just another way to do it. I should say 1.505. Okay? And then log 2 to the 7th times 5. Again, they could change it up on you, but you just have to write log 2 to the 7th times 5, close the parenthesis, hit enter, 2.806. Okay, what do you think anti-log is? Yes.
Probably log to the negative first power.
No, good try. Good try. So if you notice anything about your calculator, y'all, the inverse of operations are always above on the top line. So like sine, inverse sine, cosine, x squared, the inverse is square root. The inverse of log is also known as anti-log. And the inverse log is, do you see what that is? 10 to the x. So you actually, if you see the word anti-log, it just means do 10 to this power, 0.3012. So they have that special button 10 to the whatever. You could actually just type 10 to the 0.3012 and you get roughly 2. Okay. So very easy. The first part is of homework tonight is just punch it in your calculator and understand how to do that. Okay. Second part is the change of base formula. It's one of my favorite formulas. I taught this one year and Mr. Wooten came in to observe me like the next day, I think. This was in John's class. And he's like, he just asked the students, he's like, oh, so I love logs. Did you remember what change of base is? And they were all like, no. None of them remembered. I was like, thanks, class. And then I showed them this and they're like, oh, this is an A. And they're like, oh, yeah, we remember that. I was like, oh, brother, thanks a lot. Getting me fired. Fired. All right. So log base, any base of any number can actually be rewritten according to what's called the change of base formula by taking the log of base C of the big number divided by log of base C of that little tiny number. So you're like, well, what does that mean? How does that help me out? This is actually how it helps you out. It's very helpful, especially for engineering students and students going into higher level mathematics who have to deal with these kind of numbers all the time. But let me give you an example. If you had log base 9 of 1043, and they're like, okay, go ahead, figure that out without a calculator and without these precious calculators that you have, again, what you could do is say, okay, well, according to the change of base formula, my scientific calculator, my little, don't think of this one, okay? Think of having just a regular trig one. You would write log base 10. Why base 10? Because most calculators have log base 10 of the big number divided by log base 10 of what? What do you think?
The smaller number.
Of the smaller number 9. And so you would type into your calculator, again, if you were using a for function, you'd go, okay, log of 1043 divided by log of 9. And again, it's log base 10. It's already understood as log base 10. And I get 3.16. I have to see this on homework tonight. I have to. I'm doing this for, again, people in this class who are trying to prepare for future use in mathematics, but you've got to show me this. It's very important, along with this, by the way. But yes, I do know that these calculators that you have are fancy. And I'm sure, I think Miss Davis showed it to you last year. Do you know that your calculator actually has log base inside of it? So if you don't remember and you go to math and then you go up to where it says log base, and it actually gives you the like setup for it, and then you type a 9 here and a 1043 here, you are going to get the same number. And that's because these calculators are precious. But that's why the college people take it away. The professor's like, nope, sorry, we want you to know how to do change of base. And you're like, really? But I know, I get it. I know you're like, why? Just know how to do it both ways, okay? Let's just do one more. Like, so what if I wrote log base 7 of 25? How could you change that for me? To be what? What would be on the top? Log base 10 of 7?
25.
Of 25, okay. And again, you don't have to write the base 10. I did in the previous example, but you don't have to write it. It's understood. Over log of what?
7.
And if you do it right, your answer should be about 1.65. But I do want to see them both. All right, how do you feel about this so far? Okay, I'm actually going to show you, and I should show the other class this, 2 ways of doing this problem. Because the one way I'm about to show you is going to help you for the next 2 problems we do. So you could solve this problem, but it's going to be hard for you. And here's a couple of reasons why. Can you make a 81 into a base 6? And that's how we learned on the last quiz how to do this stuff. We would, right, if this was a 2 to the 3x and this was an 8, we'd say, oh, that's 8 is just 2 to the 3, and we can make it very easily, okay? What you could though do is the whole convert this to logarithmic. Do the whole zoop. So how would you write that? Log of 6 of 81 equals 3x, right? And then do what? How do you get x by itself? Divide by 3. Okay? And now your calculator is so fancy that it can do this part right here. I mean, you can put this in log base and divide it by 3. And just to show you what it would be, let's just, math, log base, 6, oops, I do that every time, 81, and then divide by 3. Actually, let me make sure I put that in parentheses that it won't. There we go, 0.8175, okay? So if you remember how to do that, good job. I'm proud of you. But I'm going to show you another way to do it. And this way is actually going to help us with the next problem. So that's why I'm showing you 2 ways. If you ever cannot change a base into another base, then you need to take the log of each side. Am I allowed to take a log of each side? You sure are. You could do whatever you want. You could add 5. You could square this, square that. You could square root. You could do whatever operation you want to do, but we're going to just take the log. Why we're going to take the log, you're going to see. So what do I mean by take log? I mean write the word log in front of both things. Log 6 to the 3x, log 81. And why am I doing that? Well, there is a special product rule that says, power rule, that says, what can I do with that 3x? I can put it in the front. And that's that is legitimately the only reason we do that. To get rid of variables that are exponents, we take logs, because that's what does it for us. So now, this is a number in your calculator, log 6. It's right, I can type log 6 and have that number, okay? But I don't want you to, there's a reason why for in a minute. This is a number. How do you get x by itself then? Divide by 3 and log 6. Do it at the same time. And do it on this side. 3 log 6. And so x is equal to log 81 over, let's write this a better way. What do I do with that 3 now? Where can I move it now? Couldn't I make it the power of 6? Log 6 to the 3rd. This is the same as that. You can type log 81 divided by log 6 to the 3rd. 0.875, 0.8175. Now here's why we're doing this, okay? It depends on your professor, depends on your person. I want both. I want this form, which is called exact. You must have exact form, or this would be exact to me. Log 6, 81 over 3. I would actually accept that, okay? And I want this form, which is decimal. Why is that? If you're an engineer person, this is what they would accept. If you're a math person, pure person, they would actually make you go to there. It just depends on whatever your calling is, but you need to know how to do both, okay? So this way would have worked fine. This way is how we're going to actually do the next 2 problems. How did you feel about that way, though? You're okay?
Yes.
Okay, then let me show you why we need to do it on the next 2 problems. So 3 to the x minus 1 is less than or equal to 2 to the x minus 7. See, you can't do the whole, oh, let's write it as a logarithmic and do the whole whoop and turn it around. You can't, because you got x's on both sides. And you cannot take a base 3 and make it a base 2 or vice versa. So you have to do the log thing. So I'm going to write log in front of that. And I'm going to write log in front of that. Because again, why do we do that? Whatever you do to one side, we got to do the other side. What does that word log allow me to do? It allows me to take this and bring it to the front. That's the whole purpose. When you bring it to the front, I would suggest you writing it in a parenthesis. Okay. Now, again, depending on who's your teacher, and I am your teacher, some teachers would say, oh yeah, you could just type this in your calculator right now and get the decimal. No, you cannot. I need it in exact form. So what does that mean? What do you think you're going to do with log 3 to this? What would you do if it was just 3? Not divide, distribute. That's what we're going to do with log 3. It's just a decimal. It's just a number. You're going to distribute it. And the way you're going to write it is x log 3, not log 3x, because that is totally different than x log 3. This one would be minus 1 log 3, or just log 3. So what would be on this side? What would I write over here?
X log 2.
Good. Minus 7 log 2. Okay. So think back with me. How do I solve the problem now? If I've got x log 3, a log 3, and x log 2. So now what do I do? What do you normally do? If it was just ignore the logs, what would you just do after that? Add what?
Simplify.
How?
They're similar. Combine like terms.
Combine like terms, right? Don't I get all my x's on one side and everything else on to the other side? So we're going to do that here. We're actually going to put this x to this side. We're going to minus it over. And we're going to take this and bring it over here. Well, doesn't that mean I'm just flipping these two, right? So x log 3 minus x log 2. And then bring this one over, makes it a plus now. So positive log 3 minus 7 log 2. Now what? This is the part where a lot of people always forget that they're allowed to do. How can I add them though? That's weird.
Calculator.
What? What'd you say?
Calculator.
No. Good try. I think you don't remember this, and that's okay. Because you were like, oh, if I have a 3x and an 8x, that's 11x, right? You would always do that. But do you know what you're actually doing? You're actually factoring out an x and leaving a 3 plus 8, which makes 11. And that's what you're going to do here. You can factor out an x, and what are you left with?
Log 3 minus log 2.
Log 3 minus log 2, which is just a bunch of numbers. That is like a weird decimal. And then finally, what do you do whenever you're multiplying a number by x? How do you get x by itself now when you're multiplying it? Just divide it out. Divide that whole thing out. Divide by log 3 minus log 2. Divide this side by log 3 minus log 2. Now, yeah, you have to rewrite this for me using your properties. So you have, with this 7, what are you going to do with that 7? 7 in front of a log.
2 to the 7th power.
Yeah, sorry, she's talking to me. This would be 2 to the 7th power. And what do you do when you subtract logs? How do you write it as one log? What do you actually do with them? So the log of what over what? What would you say? What comes first? 3 over 2 to the 7th. That would be the top. What would be the bottom? Log of, we're subtracting again. What? 3 over 2. That, my friends, is exact. And that's what I'm going to require on a quiz. The next quiz. As a decimal, you can put it in your calculator. I'm going to, whoops, so I can quit. 3 over 2 to the 7th. Divide by log of 3/2. And negative 9.25 is correct. Okay. Are you kidding me, Mrs. Setta? I could see that some of you were picking this up and some of you were not. Do you understand that the first thing you do is write log log? The second thing you do is move that exponent, distribute, combine your like terms, factor, and divide. You're a third of the way there. Then you distribute. X log 5 minus log 5. You could put a 1 there. It's okay, but it's unnecessary. Equals X log 2. If you got that far, again, you're on track right now.
And then you switch
What did I do after that?
what?
Swap them. Add and subtract. So minus X log 2 equals a positive log 5. Did you all write positive, right? What did I do to get X by itself?
Take out an
Factor it out.
F5.
And then divide out this. I will tell you right now, if you get this far on your next quiz, like this far, I'd probably only take off a point. You'd have that much partial credit because this is really good. You have the right answer, you just don't know how to write it correctly.
X equals
So the answer would be log 5 over, how do you write that?
Log 5 over 2.
Yes.
which equals 1.7.
Which if you put it in your calculator is 1.756. That is awesome. Yes.
I wrote 1.76.
That's fine. That's fine. Can I show you one more thing and then I bear with me? I know I'm done. Can you put this into Y1 in your calculator and put this into Y2? I'm showing you this because this is also on the next quiz and I'm about to blow your mind. Put 5 to the X minus 1 and then put Y2 as 2 to the X. Everybody do this because I'm telling you it's going to be awesome. Okay? And then when you're done, hit graph. If two equations are equal, then what do we know about their X's? They should be what? Equal, which graphically meaning they should what? Intersect. And they do. Okay, now it looks like they're intersecting right here, but they're really not. But if you hit good old Miss Davis phrase, second calc 5, enter, 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 what is that X?
1.756.
Do you know that you could be doing this for every equation that you ever have given? Like if I gave you x squared plus x equals, I don't know, 10. You put that into Y1, put that into Y2, second calc 5, enter, enter, enter. FYI, it's allowed all the time. But isn't that cool? You can do that every time. All right, y'all. Now here's what you got to do for homework. I just wanted to blow your mind on that one because I always forget until I do this part right here.